In August 2018, humanity embarked on an extraordinary journey, one that would push the boundaries of space exploration and science in ways we never imagined possible. The Parker Solar Probe, a marvel of engineering and innovation, was launched aboard a Delta IV Heavy rocket, setting off on an ambitious mission to explore the Sun like never before. This groundbreaking space probe is designed to fly closer to the Sun than any other man-made object has ever dared, and its scientific objectives promise to unlock mysteries that have eluded researchers for centuries. A mission that was once deemed impossible, and later incredibly difficult, is now a reality. As we continue to make incredible advances in technology, the Parker Solar Probe has become a symbol of humanity's ambition to understand the forces that drive our universe. The primary goal of the Parker Solar Probe is to study the Sun in unprecedented detail. For centuries, the Sun has been both a source of life and a potential threat to life on Earth. Its powerful solar winds, solar flares, and coronal mass ejections have the capacity to disrupt satellite communications, power grids, and other vital technologies on Earth. Scientists have long sought to understand these phenomena better, and to do so, they needed a probe capable of getting much closer to the Sun than any previous spacecraft. The Parker Solar Probe is the solution, designed to travel closer to the Sun than any other spacecraft in history. The Sun is far more than just a bright light in the sky. It is a vast and complex ball of hot plasma that holds the solar system together with its gravity. The Sun's influence extends far beyond its surface, and its behavior has a profound impact on the planets, moons, and objects that orbit it. Yet, despite all our knowledge of the Sun's general characteristics, there are still many unanswered questions. One of the most puzzling aspects of the Sun is the strange behavior of its outer layers, particularly the corona, the Sun's outermost atmosphere. Although the corona is far hotter than the Sun's visible surface, we still don't fully understand why this temperature discrepancy exists or how it affects solar activity. The Parker Solar Probe was specifically designed to tackle these mysteries. While previous spacecraft, such as the Helios probes in the 1970s, approached the Sun from a safe distance, the Parker Solar Probe is on a trajectory that will take it much closer. In fact, the Parker Solar Probe will travel to within 3.7 million miles of the Sun, closer than any spacecraft has ever come before. This is a staggering distance when you consider that the closest planet to the Sun, Mercury, orbits at about 36 million miles away. By getting this close, the Parker Solar Probe will be able to collect data in the Sun's corona and provide scientists with the kind of detailed measurements and observations that have never been possible before. But the mission is not just about getting close to the Sun, it's also about developing the technology necessary to survive the extreme conditions near the Sun. The Parker Solar Probe will fly through areas of space where temperatures soar to over 2,500 degrees Fahrenheit, and where the radiation levels are much higher than anything we've encountered before. To survive in these extreme conditions, the spacecraft had to be designed with a number of innovative features. One of the key innovations is the probe's heat shield, a specially designed shield that will protect the spacecraft from the Sun's intense heat. The shield is made of a carbon composite material that is not only lightweight but also incredibly effective at absorbing and deflecting heat. The shield is about 4.5 inches thick and has a special white coating that reflects heat away from the spacecraft. While the heat shield plays a critical role in protecting the spacecraft from the Sun's heat, the Parker Solar Probe is also equipped with cutting-edge instruments that allow it to take detailed measurements of the Sun's atmosphere, solar winds, and magnetic fields. These instruments include cameras, spectrometers, and plasma detectors, all designed to capture data that will help scientists understand the Sun's behavior. These instruments are housed in a specially designed container that is insulated from the extreme heat of the Sun, ensuring that they remain at a safe temperature even when the spacecraft is flying through the hottest regions of space. One of the most remarkable aspects of the Parker Solar Probe's mission is its ability to measure the Sun's solar wind directly. Solar wind is a stream of charged particles that the Sun constantly emits into space. These particles are made up of electrons, protons, and other atomic nuclei, and they can travel at speeds of up to 1 million miles per hour. When these particles reach Earth, they interact with our planet's magnetic field and can cause phenomena like auroras. However, they can also cause disruptions to communication systems, power grids, and satellites. By studying the solar wind up close, scientists can gain valuable insights into how it is generated, how it behaves, and how it affects the solar system. The Parker Solar Probe's instruments will allow scientists to measure the speed, density, and magnetic properties of the solar wind in unprecedented detail. Another critical aspect of the mission is studying the Sun's magnetic fields. The Sun's magnetic fields are responsible for a wide range of phenomena, including solar flares, sunspots, and coronal mass ejections. These magnetic fields are incredibly complex, and their behavior is not well understood. By studying the magnetic fields in the Sun's corona, the Parker Solar Probe will provide new insights into how these fields are generated and how they influence solar activity. Understanding the Sun's magnetic fields is crucial for predicting solar flares and space weather events, which can have a significant impact on technology here on Earth. The Parker Solar Probe's journey is not a straightforward one. Because the spacecraft is flying so close to the Sun, it has to contend with extreme speeds and temperatures. To navigate these challenges, the spacecraft uses a combination of gravitational assists from Venus and sophisticated navigation techniques. These assists allow the Parker Solar Probe to gradually adjust its trajectory and slow down enough to enter the Sun's vicinity. The probe's orbit is designed to take it close to the Sun, then move it back into the cooler regions of space, where it can rest and cool off before its next flyby. This process will be repeated over the course of several years, allowing the spacecraft to gather data during each pass. The Parker Solar Probe is not just a remarkable achievement in terms of technology, it is also a major breakthrough in the scientific understanding of the Sun. The data that it gathers will help scientists answer a range of questions that have remained unanswered for decades. One of the biggest mysteries is the Sun's corona, the outermost layer of the Sun's atmosphere. Although the corona is much hotter than the Sun's visible surface, we don't yet fully understand why this temperature discrepancy exists. The Parker Solar Probe will measure the corona's temperature, density, and magnetic fields, helping scientists understand what causes this unusual heating process. Another important area of research is the solar wind. The solar wind is a continuous stream of charged particles that flows outward from the Sun and interacts with the planets in the solar system. These particles can have a significant impact on Earth's magnetic field and atmosphere, creating phenomena like auroras and geomagnetic storms. However, the solar wind is also a source of potential danger to our technological infrastructure. Understanding how the solar wind behaves and how it interacts with the Earth's magnetic field is essential for protecting satellites, power grids, and other critical systems. In addition to studying the Sun's outer layers and solar wind, the Parker Solar Probe will also provide valuable insights into solar flares and coronal mass ejections, CMEs. These massive bursts of energy and particles can cause disruptions to Earth's communication systems, power grids, and satellites. Solar flares, in particular, can produce intense radiation that poses a threat to astronauts in space. By studying the Sun's magnetic fields and the mechanisms behind solar flares and CMEs, the Parker Solar Probe will help scientists improve their ability to predict these events and mitigate their impact on Earth. The Parker Solar Probe's journey is far from over, but it has already achieved some incredible milestones. One of the most significant moments in the mission came in April 2021, when the probe made its first flyby of the Sun's corona. This was the first time that a spacecraft had ever flown through the Sun's outer atmosphere, and the data gathered during this flyby provided new insights into the behavior of the solar wind and the Sun's magnetic fields. In addition to taking measurements, the Parker Solar Probe also captured stunning images of the Sun's corona, revealing intricate details that had never been seen before. As the Parker Solar Probe continues its journey, it will make additional flybys, collecting more data and providing even deeper insights into the Sun's behavior. Over the course of several years, the spacecraft will gradually move closer to the Sun, taking measurements and sending back data to Earth. Scientists will analyze this data to refine our understanding of the Sun and its impact on the solar system. By the time the mission reaches its conclusion, the Parker Solar Probe will have revolutionized our knowledge of the Sun and paved the way for future solar research. The Parker Solar Probe's success is a testament to the ingenuity and determination of the scientists, engineers, and researchers who made this mission possible. It is a symbol of human curiosity and the relentless pursuit of knowledge, showing that no challenge is too great when we work together to overcome it. As we continue to explore the Sun and the universe beyond, the Parker Solar Probe will remain a shining example of what humanity can achieve when we reach for the stars. In conclusion, the Parker Solar Probe is more than just a spacecraft, it is a groundbreaking mission that is redefining our understanding of the Sun. Through its close-up observations, we are gaining new insights into the Sun's behavior, its influence on the solar system, and its impact on Earth. As this mission continues to unfold, it promises to answer some of the most fundamental questions in space science and open the door to a new era of solar exploration. The Parker Solar Probe is not only a triumph of engineering and science but also a testament to the boundless potential of human exploration.